If a stone is thrown down at 120 feet per second from a height of 1000 feet, its height as after t seconds is given by the function s of t equals 1000 minus 120t minus 16t squared, with s in feet and t in second. Compute s prime of t, and hence find the stone's velocity at time t equals 0, 1, 2, 3, 4 seconds. When does the stone reach the ground? And how fast is it traveling when it hits the ground? First, we will compute s prime of t, which is the derivative of s, or the rate of change of the height with respect to the time in second, which will give us the velocity of the object. And so s prime in this case will be the velocity. The function s is given in the quadratic form. S of t equals 1000 minus 120t minus 16t squared. The derivative of the sum and the difference will be the sum and the difference of derivatives. In this case, we simply take derivative term by term. The derivative of 1000, which is a constant, is 0, minus the derivative of 120t is 120, and the derivative of negative 16t squared is minus 16 times 2t. We use the power rule for the third term, and for the middle term, it is linear, so the derivative is the slope. The first term, it is the constant, whose derivative is 0. Simplifying this, we have s prime of t equals negative 120 minus 32t. This is s prime of t, which is, again, the velocity. The velocity at time 0 is s prime of 0, which is negative 120 minus 32 times 0, which is negative 120. The unit will be the unit of the height, which is in feet, over the unit of time, which is in second. S prime of 1 is negative 120 minus 32 times 1, which will give us negative 152. Again, the unit is feet per second. S prime of 2 is negative 120 minus 32 times 2, which will give us negative 184 feet per second. S prime of 3 is negative 120 minus 32 times 3, which is negative 216 feet per second. And lastly, S prime of 4 is negative 120 minus 32 times 4, which will give us negative 248, and again, the unit is feet per second. All of these velocities are negative because the stone height is decreasing. Its height starts with 1000, but then because it is being thrown down, the height will be decreasing. Therefore, its velocity is negative. For part B, when did the stone reach the ground? S represents the position or the height in this case. The stone will reach the ground when its height is 0. And so we take the function s and we set it equal to 0. The function s is 1000 minus 120t minus 16t squared. This is a quadratic equation, so we would rewrite this at negative 16t squared minus 120t plus 1000 equals 0. We can solve for t to answer the question when. When is the question that asking us to find the time. We can solve for t in this case using factoring method or using the quadratic formula. If we were to use the quadratic formula, then t equals negative b, which is negative 120 plus or minus the square root of b squared. B is negative 120, we squared it, minus 4 times a, which is negative 16, times c, which is 1000. remember that the standard form of the quadratic equation is ax squared plus bx plus c, the coefficient a, b, and c in the quadratic formula, over 2 times a, 2 times negative 16. If we simplify this, we will get t equals negative 12.5 for the plus sign, and for the minus sign, we will get t equals 5. We will not use negative time here because t represents seconds, and so we have t equals 5. We will say that the stone reaches the ground 5 seconds after it is being thrown. T equals 5. How fast is it traveling when it hits the ground? How fast is the question about the velocity or derivative. In this case, we simply find out what s prime of 5 is, but we evaluate it like we did before. We plugged 5 into the derivative now, which is negative 120 minus 32 times 5. Again, the question about how fast is the derivative, how fast is the velocity, specifically in this case, this is negative 280 feet per second. We would say that the stone is traveling at the speed of 280 feet per second, where the speed is the magnitude or the absolute value of the velocity.